and then we started one at a time taking each component, and then we built up the entire Hadoop cluster in a distributed mode where we set up one name node, 3 data nodes, a job tracker, and a client node. And then we looked at various admin tasks which are done. For example, how to take a backup of metadata, how to set up a secondary name node, how to enable cluster membership, how to set up quotas, right? All those things we looked at. And we also looked at how replication plays a role, and what is the factor which decides the replication, and how we can change replication, for example, of per file or of already copied data. We also looked at rack awareness, right? How rack awareness can be configured and how why it is important, right? And we also looked at OIV viewer, right? So if you remember, OIV viewer was offline image viewer. So it was used for viewing fsimage, right? Fsimage is a binary file, so I cannot simply cat it, so I have to use the OIV viewer for it, right? So let's get started with today's class. So the agenda for today's class will be planning the Hadoop cluster, right? And we'll look at cluster sizing, how we will plan the Hadoop cluster, what are the hardware components, what are the software components we need, and how we will plan for the size of the cluster. So we will not be talking about the performance here. Performance we will be talking in our last class, right? Once we go through everything. So we will be only talking about the cluster planning aspects. We will look at Hadoop logging, right? How to set up enable logging for various Hadoop daemons, and then we will start with Hadoop 2, right? We will look at why Hadoop 1 is different from Hadoop 2, and what were the disadvantages in Hadoop 1 which were addressed in Hadoop 2. And we will look at a new framework which is called Yarn, right? So we will look at all these things. So let me quickly start my cluster, and also you should be recapping all those things what we have covered over the last 3 weeks, 3 or 4 weeks, right? So let me start up my cluster. So if you remember, so I was running one repo server which was hosting my DNS, my repositories, everything, and other was I was running my Hadoop cluster, right? So where we had various cluster setups. Let me open my Hadoop one here. So we were running name nodes, data node, job tracker, client, and secondary, right? So today we don't need secondary. We need first is name node, right? So let me just check. Okay, it's connecting to Ethernet 1. I will start my name node. I will start my data node 1, 2, 3 data nodes. I will start my job tracker, and I will start my client, right? So I hope everybody was able to set up the cluster at home. If not fully distributed, at least 2 or 3 nodes they were able to set up in their Hadoop cluster. So today we will be looking at how you plan your cluster, right? So the cluster could be a one node, right? So some people call one node as a cluster, right? Which is actually not a production grade, but still you can people call it cluster, especially the dev guys. But the pure classification of a cluster comes when you have distributed components, right? Not only the daemons, but also the hardware and the infrastructure, right? So distribution comes into place. Or there are various components. For example, you might be talking over a network, or you might have multiple servers coordinating to work as one. So the important thing about cluster planning is, or scaling a cluster, is how we will take care of disks in my cluster. how many disks I will have in my cluster, how will I expand them if I need be, how will I take care of the computing power of my cluster, right? How many cores I will put into my cluster, right? So all these factors we'll be discussing today, how they play an important role in Hadoop. So let's start first with the hardware part, right? What all things we need to take care of when we talk about hardware. Okay, so let's first of all start with the name node, right? So up till now we have discussed the role of name node. So name node is a very important component of our Hadoop cluster because it is the master, and in Hadoop one single point of failure. If it goes down, my cluster is down, irrespective of how many nodes are up. So what we will do in the case of a name node, right? Uh, I should have a robust machine which could handle failures, right? So when I say a robust machine, so the definition of the very first definition of Hadoop is that Hadoop runs on commodity hardware. So this definition is little bit misnomer. So commodity hardware here does not mean that I will bring my desktop and start running my Hadoop cluster, right? So in the case of a name node, what are the important things which we need to take care of, right? When I say name node, any of the master, this could be valid. So the master could be a name node, it could be a secondary name node, it could be a job tracker, right? The masters, right? We are not talking about data nodes, right? We'll come to them a little bit later. So the first requirement of a name node is the memory, because the entire metadata of your entire cluster sits into the memory of the name node. So the first very important thing is the memory on your name node should be big enough to handle the metadata. So the formula I told you, how you calculate what should be the memory for storing the objects. So the rule in the market is for 1 GB of memory on the name node, I can have 1 million files, right? When I say files, considering each file of 2 blocks, right? So roughly I can have 2 million blocks for 1 GB of RAM on name node, right? So I will plan accordingly. So what should be the size of my Hadoop cluster? So this is in addition to the memory requirements for the operating system and the memory requirements for the JVM of the daemon itself, right? So let's start one by one and look at first the memory part of name node. So on a name node, what will be the first thing, right? I have to have some memory for the operating system. Then I have to have some memory for the name node daemon itself, right? How we decide that, right? If you remember from our classes where we were specifying this, right? So let me log into my node and let me show you where we were defining that, right? So if I go to my name node, let me make this screen a little bit bigger, right? So I'm sitting on my name node, which is nn1.cluster1.com. I change my user as Hadoop. Yes, this was the user with which we are running Hadoop. cd hadoop config vi hadoop env.sh, right? Hadoop env.sh. So this was the Hadoop environment file. If you remember, this was the file where we specified where the Java should be. What should be the heap size, right? This is the parameter which decides the heap size of the JVM of your daemon which runs on this node, right? Whichever daemon you start on this node, it defines the memory for that, right? So on this node we were running name node daemon. So here we are specifying 300 MB of memory for the name node, right? So this is not a production cluster. We have a very small cluster, very small data. So this will work. But in your real production cases, this memory will be quite huge, right? This memory will be quite huge, right? Around 4 GB we will giving just for the daemon itself. Why? Because daemon has to do lot of things. What it has to do is, so as we discussed in our classes, all the advertisements which are coming from data node, it has to address that. It has to build the bitmap. It has to build the metadata. It has to respond to file read or write requests, right? It has to fire commands to tell to a data node whether to copy a file, invalidate a block, right? Or send a block report, right? All those things it has to calculate. So it needs memory for itself to work. So in addition to these two factors, the memory which you need will be memory for the metadata, right? The formula which I told you for, right? For each 1 GB of memory, you can have 2 million blocks, HDFS blocks, right? So it will decide the size of your Hadoop cluster. Another thing, as I said, name node is a single point of failure. If my name node goes down, my cluster is down. So what I will do, the server which I will choose for my name node should be of enterprise class, right? So when I say enterprise class, it does not mean that it will be a dome server or GS 1280s and all that boxes. No, right? What it should have redundant power supply, right? The SMPS we have at the back of our box, right? It should have multiple power supplies. It should have multiple NIC cards, right? So that if one NIC card failed, the other can still work. And there are another also reasons why we have multiple NIC cards, right? We can team them together for a higher throughput. This is SMPS, power supply unit. Another is the RAID hard drive which I will be using on my name node should be in RAID 1, right? RAID 1. Why? Because the metadata which is stored on the name node is never replicated. What is replicated? Only the data on the data nodes, right? So when I say replication is 3, right? When I say the replication is 3, replication is valid only for the data, not for the metadata. So I have to take into account any failures for my name node. So only on name node I will have a rated hard drive for my name node metadata, right? So if I go back to the configuration vi hdfs-site, I'm talking about this parameter. Wherever I am telling name node to store metadata, this partition, right? Currently, if I do df-h, right, you can see it is a single hard drive mount, right? But in your production system, this will be raided, which will be presented to the name node, so that if one hard drive fails, you still have the name node running. RAID will be both for the operating system disk as well as the name node metadata disk, right? In the case of name node only, right? We will not put RAID on data nodes because already we are replicating data 3 times. So I have a question from Shiva. He's asking, when you say 2 million blocks, considering the block size is 128, it does not matter, right? It does not matter. So as I told you, right? So what was the formula? How we was calculating the object size? Let's say I have a file 1.txt which is 128 MB in size, let's say, right? My HDFS block size by default is 64 MB in Hadoop 1, right? So what will happen whenever I copy this file to Hadoop file system, this file will be split into two blocks, each of 64 MB. So now what will be the object size in the name node memory of the name node? It will be 150 bytes for the file name itself and 150 each for the block. So I will have 150 plus 150 for the two blocks, 450 bytes, right? 150 for the byte file name and 300 bytes for the blocks, which will be needed in the memory of the name node to address the data structure. So even if I have, let's say, larger block size, 128 MB, correct? 128 MB. So what will happen is now I can store everything in one block. Memory will go down 300 bytes. But what I was saying, 1 GB for 2 million blocks, I'm saying, right? So the memory on your name node does not matter whether the block is 64 MB or 128 MB. It will still be using 150 bytes per block, right? So the total number of blocks will be 2 million blocks per GB. Okay. So name node, right? So name node, first is we should make the memory sufficient so that the entire metadata can fit. It should have multiple power supplies, RAID hard drives, multiple NIC card, right? We will see why it should have multiple NIC cards in a little bit later. Same will be true for secondary name node also, because secondary is also a master. Master for what? Let's say if my secondary goes down, I will not have checkpointing happening, right? So as I explained you in our previous class, we did a practical on this. So if I have a name node, primary name node, and I have a secondary name node, if secondary name node fails, I will not have an outage. Production outage will not be there. But what will happen? My edits on my primary name node, the journal, will keep on growing bigger. I have to manually restart the name node. That will cause an outage. Or let's say if my secondary is down and my primary fails due to some reason, I cannot fail over, right? And I will have to go by manual ways of recovering. For example, I have to move the hard drive out of these boxes, put in some other boxes, and bring up that box as a primary name node. So if my secondary is up, what will be the advantage? It will be doing checkpointing. And also in case my primary fails, I can promote my secondary to be primary name node, right? I will show you that also, how we can do that, right? The simple thing will be how you can do that is because secondary is already pulling your metadata, right? It is pulling metadata, let's say every 1 hour. Every 1 hour it is pulling the metadata. And on the name node, as I told you, in addition to a single mount point, right? Slash data slash name node, which might be a RAID hard drive. But what will be disadvantage of this? Although my hard drive is into a RAID one, but the hard drives will still be on a single system. What will happen in this case if some failure happens and I do not have access to that box? So what I have to do, I have to call my data center guy and ask him to please move the disk manually from this node to another node, which might not be the feasible solution. So that's why I told you what we will do in production. In addition to having a RAID hard drive, I will also mount an NFS location here. So I will ask name node to write my metadata also on a filer and also on a RAID hard drive within my system. And that filer I can access anywhere. I can NFS mount anywhere, right? So that is important from a name node perspective. Also, secondary should be having the almost the identical to the name node, right? Same amount of memory. In case I have to fail over to secondary, it should be able to handle the traffic, handle the metadata, right? And also for job tracker. Job tracker is again a master for MapReduce layer, because all the task trackers are talking to it. So whenever we submit a job, it first goes to the job tracker, and job tracker is the one which decides where the job should be fired, right? So it will say job should go on data node 1, which is having task tracker 1, right? So job tracker is also a single point of failure, so we should have high availability, or for example, we should take care of high availability in terms of having multiple hardware components, right? Power supply, disk, and all that. So on the slave side, right, which are data nodes, we don't need to worry about their failure. Okay, yeah. So another question here is there any specific reason why we need to have NFS first? Yes, there's a reason, right? So I was telling in my example here, I can put NFS here. So why we always give NFS first is to make sure it is writing to the NFS at the very first instance. So what will happen is, let's say if I'm writing to this RAID first, it might happen that it crashes after that, right? It might crash at any instance during writing to name node, and I will have still same problem because it might not have reached NFS. So I'm making my best guess, best effort that it should fail at least after writing to NFS, correct? And the NFS we will do will be with no lock option, right? NFS mount which we will do, which will do with no lock option. Okay, so now coming to data nodes. So on the data node side, we don't need to worry about high availability for data nodes. Why? Because that's what Hadoop is designed for. So from the very beginning, the idea behind Hadoop design was have a name node and have many data nodes, means slaves, maybe 3000, right? But this is still rare in production, right? Other than companies like Yahoo, Facebook, or Google, they do not run that big clusters, right? On an average in the outside market, you will see clusters around the size of 400 nodes, not bigger than that, right? So even in that 400 case, I can afford to fail 10 nodes or 20 nodes, right? I can afford to fail data nodes because I have 3 copies of data in my cluster, but name node I cannot afford to fail. So any data node can fail, data will be available on another machines, right? Although my computing capacity will go down, no doubt, but I will not have outage or data loss. So I do not need to have hard drive raided on my slaves. So what will happen if I put, let's say, a RAID 1 on my data node 1? What will happen? One is its capacity, disk capacity will go down by a factor of 2, because mirror one you are putting, you have to put 2 disks minimum, right? So if I'm putting 2 disk drives of 1 terabyte each into a rated hard drive, it will be 1 terabyte space will be available to me, and that too having now 6 copies, right? Because 3 is the default and I'm also raiding the hard drive, 6 copies, I'm wasting space, right? So I will not put RAID, I will not put multiple power supplies because I can afford to fail them. I want my cost to be less, right? So they will be running on little, you can afford to run them on cheaper hardware as compared to Namenode. So in production, for example, in companies like Yahoo, there are multiple setups which we were running. So example could be Namenode will be the master, right? Or job tracker, in the case of a job tracker also, the memory will be high, right? Memory will be 128 GB. But on these data nodes, 12 GB, some had 24 GB, those kind of memories you will have, right? And you will have multiple number of nodes. So the important thing here is we have how you will plan your cluster, how you will size your cluster. So actually you have to see what kind of workloads you have. Are they compute intensive or IO intensive, right? So what does it mean, right? Let me give you an example. Let me clear the screen, right? Compute intensive could be I have my data in memory and I'm doing some computations on them, right? For example, Spark, Storm, these are also tools of big data, right? But let's say forget about big data, we talk about our traditional namespace. Any data which I have in my memory or cached, right? I can quickly work on it, right? Any algorithms, right? Any machine learning algorithms, it may be linear regression, whatever, right? If you are doing computation, it is CPU intensive. But if you are reading or writing to disk, it is IO intensive, right? So your workloads will be always a combination of these. Either it will be very CPU intensive or very IO intensive or a mixture of both. So in the case of my name node, it is more of combination of CPU and memory intensive. My name node, right? My data node is more of IO intensive and a little bit of CPU, but not on memory, right? Because has to write data from multiple disks it has. So I have to plan accordingly, right? So I should not be doing an oversizing here, right? Let's say I start my Hadoop cluster and I procure more number of nodes than what I need, right? So it will be a problem for me. Why it will be a problem? Because I have to justify the cost which I am running it with, right? Because my end of the day, my data could be very less. So let me give you an example. Let's say if your data is growing at roughly, let's say I've given 10 here for the ease of calculations, a round figure. Let's say your data is growing at 10 terabytes per week, right? You are a Hadoop admin or the architect who has to plan the Hadoop cluster capacity, and you have to plan well in advance because you have to order servers, right? I cannot order a server in the morning and it will get delivered in the evening because there will be a lot of approval processes because money is involved. So I should plan things in advance. So how will I plan, right? So let's take an example. I have 1 terabyte of data which I know every week I will be growing at a rate of, let's say, 10 terabytes of data per week will be flowing into my system, right? So let me go to whiteboard. Okay. So now as I'm saying 10 TB of data, 10 TB of data, let's say per week. So now this data is going on to Hadoop into 3. Why? Because this is replication, right? My replication is 3. So it becomes 30 terabyte per week. Now, let's say I'm buying servers. Each server has each hard drive with 3 terabyte and total number of 10 hard drives into it, right? So it means one server can serve me 30 terabyte of data. Taking the combination that each server has 10 hard drives and each hard drive is of 3 terabyte. So what does it mean? Every week I need one server, right? I'm giving you round figure. It could be more or less number of servers, right? I will come to that. How much data you should have per server, right? I will come to that point. But now I will have one server per week. So what I can calculate is I can say now that over a period of 1 month, I will approximately need 4 servers, right? So I can plan that way, right? And I can say into 6 months, I need around 24 servers to be available over a period of 6 months, right? This is just purely from storage point, right? I will come to the computing part later, right? This is just from a storage part. Now, I asked the one question here, 30 terabyte, right? So let me just clear the screen. Let's say I go to market and I have a choice of buying servers, right? What choice I have? First server has, it gives me, let's take a hypothetical case, although that big hard drives are not available. Let's say I buy a server with just 2 hard drives, each 15 terabytes, right? I'm giving a hypothetical case. 15 terabytes singly is not available. And I have another option of buying a server with 3 terabyte having 10 disks in it, right? So which one should I go for and why, right? First case, right? So obviously, as I explained you in the very first class, my choice will be this. Why? Because I will have distribution here. Why distribution? I will have multiple disk drives to read in parallel, to read the data in parallel, correct? In place of this, right? So I think I have explained you this in the very first class, but I think I have put up a one more slide here. Yeah, right. So this was, if you remember from the very first class, I explained you this. So the concept here is, let's say I have 1 terabyte of data and how distribution is helping me read it. So let's take a very first case. How I was explaining you, I have a system. I have to read, let's say 1 terabyte of data from it, right? Read or write. Let's say this system has 4 hard drives, right? And each hard drive will have some read write speed, right? So let's say best case 200 megabits per second, right? Although we have faster drives, SSDs and all, but very costly, but we are going with simple SATA. So I have 4 hard drives. Each hard drive is of 250 GB. So what does it mean? My entire 1 terabyte can sit in one server on 4 hard drives. So how much time it will take me to read 1 terabyte? from one server 250 GB divided by 200 MB, right? So it will approximately come around 45 minutes, right? If you do the calculations. So if I keep on moving to multiple servers, this number goes down, right? So if I have explained to you this in detail in our class 1, right? So how having multiple nodes, I will have now, let's say I have 10 servers, now I will have 40 hard drives. And again, the number will go down by a factor of 10, right? 4.5 minutes. If I put 100 nodes, around 45 seconds, right? So having multiple nodes, it will increase the distribution and parallelism of my reading writing data. So my throughput will be better, right? Obviously, right? So this is a clear cut that having more disks will increase my performance. But now the challenge comes, right? Here, obviously the assumption is your system have that many slots for your hard drive, which is not a problem in modern day systems. You have multiple SATA drives. Even your desktops easily has nowadays uh, 8 to 10 slots, SATA slots, right? And servers has a lot of them, right? So it's not a problem. So now what will be the case, right? First, distribution is clear, no doubt about that. Now the second point comes, how much data I should put on one server. Should I put 10 TB or should I put 100 TB, right? So first case I was given you of distribution. Now let's take a second case now. I again have a choice. Let's say I can build just one server having multiple hard drives to store, let's say, 50 terabyte of data. Another case what I can do is I can have lesser number of hard drives, right, and have more number of servers, right? So what we are trying to understand here is, first case we looked at, it is always better to have more number of hard drives per system. But now the point is how much data, right? What should be the total capacity per node? So the market Hadoop recommendation is, right, it when it started it was very less, but in our case, for example, in production also we go till 30 terabytes of data per node, not beyond that, right? Why we do not go beyond that, right? Let's say I have 10 disk drives, each with 3 TB per server. So I can have 30 terabyte per server, but we will not go beyond it. Why we will not go beyond it? Because larger the data you have on a node, larger the data you fill, right? Let me repeat it or rephrase it. More the data you have on a node, more the data you lose, right? What does it mean? If I have a server with just 5 TB of data, and if that fails, I have to just replicate only 5 TB of data. But if I have a server with 100 TB of data, and if that fails, it will take me longer time for the recovery part, because now 100 TB has to be replicated from the remaining nodes, right? So the replication will take longer, cluster traffic will increase, replication traffic will increase, your performance will go down, because now the computation between the nodes, right, the data transfer between the nodes will be slow, because 100 terabyte data is occupying your bandwidth, because it is trying to move the data across, right? So now it is also very important to have distribution, more number of hard drives, but same time we have to keep into account not to put too much data on a node, right? 30 terabyte is good enough, right? That too also for big companies which have a lot of data, but the companies who start or do a POCs, having around 2 terabyte hard drives, put around 4 hard drives, right? 8 terabyte per system. No need to go anything beyond that. Okay, now, so as I said, on data node, we will never use RAID. So we will always use JBOD. So in the audience, most people are from Linux. So probably I don't need to explain, but let me tell you for the sake all those people who are not aware about from a systems background. So JBOD is just a bunch of disk, right? JBOD, what it will do, I'm not configuring it into any kind of RAID, striping. I'm not doing anything. I'm just presenting the entire hard drives I have. What will it, if it will do? It will have a controller. Let's say at the lower level, it has some controller here, and I'm just plugging hard drives in that. It has multiple hard drives. These all are hard drive slots, which are plug and play, right? I can just insert hard drive, remove hard drive, right? Just a storage, just a bunch of disk. It's presenting me as a storage. I will use that in data node, right? So when I say storage means, does not here mean that I will configure a NAS or a SAN or a filer. All the disks will be on the server itself, right? It will be kind of a DAS, direct attached storage to a server. It will not be a SAN NAS. In Hadoop, we do not use SAN NAS. The disadvantage is the locality of reference will go, right? So what was locality of reference? Locality of reference was, I was explaining you, when a job tracker submits a job, which data node it submits a job on? The data node which has the actual data on which job needs to run. But if I put a storage here, right, and this storage is mounted on all nodes, right, it beats my purpose. A storage will be a bottleneck in that case because everything will be hitting the storage, right? So we do not use storage. So there is a very interesting use case from Aadhaar project which we are running in India, right? They initially started with Cloudera and they started using NAS, right? This did not scale. Then they moved to Mapper distribution, right? And they moved out of NAS, right? Very interesting case study. Just search on Google, you will find that. Why did they did so, and what were the advantages of coming out of that? Okay, now we have seen about cluster sizing in terms of storage, right? So this is why I explained you. Data nodes are IO intensive. Better to have multiple disks rather than a single large disk. Distribution of data across multiple disks. Higher throughput when data is spread across disks. Right? How quickly I can read 1 terabyte of data. This is what I explained you here. Right? Having multiple distribution. But now, another very important factor which we consider, right? Especially in Hadoop, it is very important that you might have seen in any of the enterprises, right? Even in Linux servers or anywhere, we will have hard drives from the same vendor. Obviously, it might be to do with the contract, right? I might have a contract with, let's say, a Samsung, Hitachi, Omega, right, for supplying me hard drives. But in addition to that, it has to do with the performance as well, right? Why we go with the hard drives from the same vendor, and it is very true in the case of Hadoop. At home, in my desktop, we don't care. I may have 3 hard drives, each from a different vendor, each having a different RPMs, right? It does not matter. But in Hadoop or distributed computing, it matters, right? Why it matters? Let me explain you that. What is the standard in the market? Standard is the smallest allocation unit on a disk, which is called a sector, is 512 bytes, right? That's the only standard. After that, if you open a hard drive, right, it will have a metallic disk, right? It will have a spindle which will have tracks on it, right? Similar to a racing tracks, multiple tracks, right? And these tracks are divided into smaller sectors, right? So this is called a sector, which I'm saying 512 byte, right? This is a sector. So this one is a track, which you see here, right? This is a track. So this entire thing is a track, the outer one, right? So standard is 512 is the size of the sector, but how many sectors I will have per track, or how many tracks I will have per disk, it's not a standard. It will vary from manufacturer to manufacturer, right? Some might be having a higher density, some might have a lower density. For example, I may buy a Samsung hard drive which is having 2 terabyte capacity and having just 2 spindles, right? That magnetic disk. But Omega might have 4 spindle disk, right? Because they are not having that high density. So what is the impact? When I go for a similar kind of a vendor, my data distribution is same across all the hard drives, right? And I will have a better parallelism read within a disk, right? So first thing is, always go with a hard drive which has multiple splint spindles, means that magnetic coatings. What does it mean? Low density disks, because it will have more number of platers, and your head, which is a reading assembly, can read in parallel from multiple cylinders at a time, right? So this is how it will be. So tracks are there, and each one is divided into a sector. These are called spindles or platers, right? More the platers you have, more parallelism you will have, because how the heads read, each platter will have two heads, one to read from the top, one to read from the bottom, same for each. So if I have here 5 platters, I will have 10 heads, so they will read from each, right? So what are cylinders? Cylinders are the same symmetric ones on top of it, right? What does it mean? If I have a disk, this one, I will have a similar disk underneath it, right? Underneath it, right? So cylinder will be a combination of track from the upper layer, upper platter, and a lower player, right? Data is stored that way. So this is what will make a lot of difference in production systems, right? I will have this from the same vendor. Second is, the standard hard drives which we buy will be 30 7200 rpms. We go for 10,000 rpm ones, right? Means the rotation speed, right? Each disk has a spindle motor underneath it, so how quickly it rotates, what is the rpm speed, it also matters. So we go for always 10,000 rpm one at the minimum, right? Not 7200 rpm. We do not go for 2.5 inch disk drives in production, especially in the case of Hadoop. Why? These comes in 5400 rpms. They are designed for laptop smaller disk. Also, the rotation speed will not be that great, and in the case of these smaller disks, your data density will be high, right? So that's why we go for other disks, right? So these they will make a little impact to the performance, and in a system where we have, let's say, 20 hard drives per system, you can see a negligible difference, right? I will show you when we do performance tuning, HDFS benchmarking. In my system, how will I demo you? As I was showing you, in my each of my data nodes, I have multiple hard drives, virtual hard drives, if I give my virtual hard drives from my separate physical hard drives, right? Let's say I give this hard drive, virtual hard drive, from physical hard drive 1 and this from physical hard drive 2, my performance will be much better, right? Or you can see a lot of noticeable difference. But if I give from the same one, you will see a contention being happening, right? In the case of a virtual machine, the reasons are different, but that's the idea behind it. So this is JBot, right? I'm saying just a bunch of disks. You have simple hot swappable disk. So in Hadoop, currently in Hadoop 1, we do not support hot swappable hard drives. What does it mean? I cannot swap a hard drive from a running system, right? Datanode does not support. But in Hadoop 2.4 and higher, that is supported, right? Swapping, hot swapping of the disk drives is supported. Now, other important thing is, in addition to disk and all, I should have multiple hard drives, right? Oh, sorry. In addition to the multiple hard drives, I should have multiple cores, right? And obviously good amount of memory so that swapping does not happen. It should not swap. So what happens in the case of a Linux, right? Swapping happens, right? Because that's how virtual memory works, right? How it has been designed to swap things out, right? It will page out the things to the disk. But in Hadoop, that's not the case, right? Hadoop will not swap out things. It will never swap out your metadata of the name node to a disk, right? It will give you out of memory error, but it will never swap it out, right? So you should have sufficient memory. So swapping could be avoided from an operating system perspective. Better to have more memory. Okay. Another important point here is have multiple CPU cores. So what does it mean, right? So let's say I have a data node, a machine, physical machine, let's say which has 8 GB of RAM, right? 8 GB of RAM. Forget about the OS requirement, daemon requirement, everything, right? Let's say my entire 8 GB is available for me to run a MapReduce job, right? So I explained to you on that day, each mapper by default takes 1 GB and reducer takes 1.5 GB. So let's say 2 GB, right? Mapper, each mapper when it runs takes 1 GB, reducer when it runs takes 2 GB. Okay, guys, can you can you hear me, because I see few people pinging me and saying they're not able to hear me. Can someone please confirm? Am I audible? Okay, I think there might be some network glitch. Okay. Okay, so I was explaining you 8 GB. So each mapper takes 1 GB and reducer takes 2 GB, right? Configurable parameter. But right. So what does it mean? Let's say I'm a Hadoop admin and I blindly say, okay, forget about reducer for the time being. I say my system data node has 8 GB of RAM, mapper takes 1 GB, so I can run 8 mappers here, right? True, true. In terms of memory, I can run 8 mappers. But can I run 8 mappers in parallel or not? It will depend upon how many CPU cores I have, right? Let's say if I have a CPU which is only a single core, doesn't matter how much memory I have, I can run only one mapper, right? Although 8 mappers, 20 mappers, 30 mapper might be assigned on that box, but only one can run at a time because there is only one CPU core, right? So important to have when we say distribution, right? So distribution is about everything, not having multiple, just having multiple hard drives or multiple systems, also at each system having multiple cores as well, right? Distribution at each level. So what does it mean? Currently all our Intel architectures, right, they are coming with HT flag enabled, right? Forget about VT and other flags, right? We are not talking about that. HT flag enabled. What does it mean? Hyper threaded. All cores are hyper threaded. So what does it mean? If I say that I have a CPU, one core CPU, right? And HT flag is enabled on that, it means it is hyper threaded, means two threads run on it, right? Two threads run on it. Even at your home, the desktop CPUs which you use Intel, anywhere from out after 2010, even in India, all CPU from Intel you will get, they will be HT enabled. So when I say I have a CPU with two cores, it means each core is hyper threaded, has two threads on it. I can run four process you can see in running. For example, if I go to a Linux box and I say ps -ef or aux, right, ps command, when I execute, how can I find how many cores I have, right? Obviously I can do a cat proc CPU, right? I can do a cat proc CPU info here, right? No doubt about that, right? To see how many cores I have, right? But if I do ps aux here, it will show me processes in various state, right? It may be a running state, it may be a waiting state, a zombie state, right? So what I will see, if I have only one single core, right, and if it is hyper threaded, means two threads, only two processes can be in running state at any given time, no matter what. So it is very important to have multiple cores. So if I go to my machine here, I go to settings, I go to system, right? You can see I have given only one core here. So that's why only you can see one CPU core in cat proc, only one CPU core, right? So I can control that in a virtual machine. In a physical machine, obviously it will give me all which I have at the physical layer, right? Processes. So now coming back to the discussion, important to have multiple cores, right? In addition to having memory. So now the question comes, how many tasks I can run, right? So let me see, I should have not mixed few slides. Okay. Oh, I think I have given this job tracker slide little bit ahead. Let me just go down. Okay, yeah. There's slight error in the ordering. This slide should come little bit later, right? So forget about this slide. So when I say multi-core CPUs, obviously there will be multiple channels to the cores which will be available, right? It will not be going through a shared channel, right? So let's say if I have a die with multi-core CPU, initially when it started, the how the bus on the CPU used to go was, it used to be like this. It used to be a shared channel, right? But now they are not coming like this anymore, right? Each CPU core which I have will have its own bus with its own caching, L1 L2 caching, right? So all these things are not a problem now, but main thing you have to look into, that blindly I cannot say that my memory is 8 GB, I can run 8 mappers, right? How many mappers can run, it will depend upon the cores you have, right? So currently we are running a lot of servers. We are also running GPU in our productions cluster. GPU is a graphic processing unit, and the server which we are running is having 1024 cores, right? 1024 cores. It's a very high end server which is used for algorithms, right? Machine learning algorithms. But that's a very rare case, you will not find outside. So mostly the people will be using Xeon processors, 16 cores, 32 cores, right? Those kind of configurations, right? CPU with 32 cores in production, right? Not beyond that. So in addition to CPU, other important thing will be the memory, right? Memory will be in addition to CPU, memory, uh, we have also another important thing is network. So in Hadoop, we will always give it a dedicated network or a VLAN. What does it mean? I will not put my Hadoop traffic on the same network which is used for something else. For example, let's say in a company, I have a switch here, right? Simple, maybe a Cisco switch, any switch, and this is my Hadoop cluster. I will not plug my Hadoop cluster into the same switch where I'm plugging anything else. Let's say I'm streaming some videos, right? My company is video streaming company, right? I will not use it on that one. What I will do best is I will give separate switches. If not possible, I will set up a VLAN, right? VLAN is a networking concept, which means virtual LANs. I will segregate a separate LAN for my Hadoop cluster, right? There are multiple reasons for that. One is Hadoop deals with large amount of data. Lot of data is moving across. So I want to keep it separate. So what we will do is each server in my Hadoop cluster will have multiple LAN cards, means NIC cards. Reason is first reason is redundancy. If one fails, other one can still work. Second reason is throughput, right? Throughput will be high if I have multiple NIC card. For example, if one NIC is of 1 Gbps and I combine two, I can get combined 2 Gbps, right? So in Linux, this concept is called bonding, right? I can create a bond zero interface, or in the word of Cisco and all that, this is called NIC teaming, right? So I will team them. So I will have two NIC cards, two cables will go from it, right? One cable will go to one switch, right? Second cable will never go into same switch. It will go to a separate switch. Also for high availability, because if switch fails, I should also have a multipath, right? Similar to multipathing to reach that. And I have also a high throughput, right? All these things will be taken care in the Hadoop infrastructure, right? But one really very important factor which we enable in Hadoop is by default on Ethernet, the MTU, maximum transmission unit for an Ethernet is 1500 bytes, right? To be very precise, it's 1496 bytes, right? This is the maximum frame size or the packet size which can go on a wire, right? In the case of Ethernet network. But in Hadoop, we are talking about large data, right? Where I might be transferring blocks very big, right? 64 MB, 128 MB, right? So how I can do that, right? For example, let's say my block is 64 MB on a Hadoop. I am sending this block from one node to another node. So what it is going down the network layer. It is getting fragmented, small fragments, small fragmented. It will going to the over the wire to the other system. Other system will again reassemble it back, right? And send to the upper layers. So this will be 1500 bytes. So imagine 64 MB divided by 1500 bytes, very big number, right? Approximately it will be 40,000 if I remember correct, do the calculation correctly. 40,000 packets it has to go for one block. So what we'll do is we enable jumbo frames on Hadoop cluster networks. The spelling is Jumbo, right? You can search on Google what is jumbo frame. Jumbo frames are the frame which are bigger than the standard MTU sizes, right? So we are using 9000 bytes MTU size, right? So how you do that? You go to your interface, put MTU is equal to 9000, right? If I open the interface here, vi etc sysconfig network scripts fcfg ethernet, and I will go here, write MTU is equal to 9000, right? And it will be enable jumbo frame for me. But just enabling here will not do the work. Why? All the devices which are in my network path should enable have support for jumbo frames, right? So what does it mean? If I have a server on which the NIC card which I have put supports jumbo frame, fine, 9000 MTU. I have set up in Linux, like currently all Linux kernel support jumbo frames, so not a problem. But if I am connected to a switch which does not support jumbo frames, right, it will again be 1500 bytes. It will renegotiate, breaks again, breaks the frame blocks into smaller size, right? So my entire path, all the devices in the path, maybe a router also in between, whatever it comes, has to have jumbo frame supported. So we put separate special kind of hardware also for my Hadoop cluster to run. So if you see in the diagram, each data node will have multiple NIC cards. That's why you can see multiple wires coming from it. And also the switches, right? Let's say if I have a switch port with 10 Gbps speed, I can combine four switches, four ports to get higher throughput, right? So this concept is called link aggregation, right? If somebody wants to go into detail, they can reach out to me. These are all networking concepts, right? So the moment we configure a bond interface in Linux also, right? If I open this file, right? Currently, my file is very simple, ETH0. But if I configure a bond interface, it will become bond 0 here, and IP and all that, everything will go into bond 0 interface, and these will just be having a MAC addresses and all. And I will say bond 0 has members ETH0, ETH1, correct? And by default, the moment I enable bonding or teaming, whatever it's called in other technologies, LACP gets enabled, right? It is link aggregation control protocol by default. In Linux, we don't have to do anything. The moment we configure a bond interface, LACP gets enabled by default. But in the case of switches, I have to enable it, right? The moment I enable a trunk port and I will set LACP tagging type, it gets enabled, right? But all those are networking concepts, right? So we are almost more than half of our class, through more than half of our class time. So let's take a quick break, tea coffee break, and we will be back in about 2-3 minutes, and then we will get started, right? Then we will see some things on the system, how we do logging and all that, and then we will start with Hadoop 2, right? So I will show you how to set up a Hadoop 2 cluster, and we have already seen Hadoop 1, and we will do a dive into Hadoop 2 from now on. We'll look why Hadoop 2 is needed, how it is different, how we will set up, right? All those things we will talk about, right? Let's take a quick break, come back, and we will get started with Hadoop 2. Okay, so let's get started. I hope everyone is back. Okay, so let me give you another example here before we move into the logging and all from a planning point perspective, because that's really very important. So let's say I have servers with me in my Hadoop cluster, and each server has 4 TB storage capacity, 4 GB RAM available each server, right? And let's say I have 100 servers, 100 data nodes available with me, right? A user comes or a business unit approaches me and he says, we need to use your Hadoop cluster for our data processing. We have some computing requirement, right? We want to process our data. And what I ask them, right? So I will ask them first of all, what is your data size, right? So they tell me it's 2 terabyte, for example. Okay, I will say 2 terabyte. Okay, I will make my calculation in my mind. 2 terabyte, they are saying rough data. So it is 6 terabyte because replication is 3. Then I will ask them, what is your retention period, right? How long you want to retain your data, right? Right. So let's say they say 1 month, right? My retention is 1 month, right? So when I say 2 terabyte of data, so another question I will ask is 2 terabyte data is what? Every day you are getting 2 terabyte of data, or you will be starting by 2 terabyte of data, right? So I will take all these factors into account, right? So let's say 6 terabyte and retention is 1 month, and they're saying 6 terabyte of data, approximately 2 terabyte of data they will be getting per week, right? So I will say, okay, per week 6 terabyte, so retention is 1 month, so I will calculate into 4, so 24 TB they need of the disk space, plus 30% we calculate for the temporary space, right? Whenever we run a MapReduce job, it writes some temporary data, right? So we'll come to the details of that. So we'll calculate some margin for that, right? But let's say till now 24 terabyte is my best guess. So I will say the business unit who is saying 22 terabyte data per week they will be using, and retention is 1 week, so I can give them 4 terabyte of my cluster. So what I did, 24 terabyte of my data. So what I did, I took 6 nodes, each node having 4 terabyte, and I took 6 nodes, 6 nodes, and I gave them to the business unit, right? Right. But the very important thing I missed on. What is that very important thing which I missed down? I never took into account the computing power. So when I'm saying 2 terabyte of data, right? 2 terabyte of data, obviously they will not be just using my Hadoop cluster just as a storage. They will be working on it, computing on it, right? So my question will be 2 terabyte of data. Okay, you need to work on. My HDFS block size is 128 MB, right? So now 2 terabyte divided by 128 MB will give me n number of blocks, right? So I will now get an idea how many mappers they might need to launch for processing 2 terabyte of data, right? So for example, so let's say if I divide 2 terabyte by 128 MB, right? So let me pull up a calculator. right? 2 into 1024 into 1024 divided by 128, right? It gives me this big number. These many mappers I need, right? By default, right? They can reduce or decrease, but this is their worst case. If they need to process the entire 2 terabyte and they launch jobs on that, they will need they can launch 16,000 mappers. Each mapper takes 1 GB of memory. 16,000 GB of memory I'm looking for. I'm looking for 16 terabyte of memory. My node does not have 4 terabyte. 4 GB is one node into 100 nodes, right? 400 gigabytes I have, right? So how will I account for these things, right? So I have to give them saying, okay, your data is 2 terabyte, but what I can give is, I cannot give you 16,000 mappers. I can maximum give you a particular slot, right? What I will do, although I'm giving you 6 nodes for your storage part, but I will give you a computing capacity of, let's say, 100 mappers. So what you will say, 100 divided by 40 is approximately 22, sorry, 25, right? 25. So I have to give him 25 servers here, because from a storage perspective I might be able to survive just by giving 6 nodes to him, but from a computing point of view, if if I let him run all the jobs, which is not possible, I cannot run 16,000 mappers because I do not have that much memory. So I reach an agreement to him. I talk to him. I say, no, I can give you only 100 maps because I can give you only 25 servers computing capacity, because other people will also be using my Hadoop cluster, right? And then giving 25 servers, I will decide on the SLA. I will say, if I give you 25 servers, you can run 100 maps, right? And your total maps are 16,000, right? So 160 instances you have to launch, right? So it will take X amount of time, right? So time we cannot predict, right? Sometimes your job might finish very quickly, sometime it might take longer time depending upon what other load or job is running. So being a Hadoop admin, what consideration you will take, not just from a storage point but from a computing point. Storage may always will take less number of node, but computing will always need more number of nodes, because your RAM is always less than the disk you have, right? So this is how we will be roughly doing a calculation. Oh, okay, so I have a question here to repeat on the memory calculated per node. Okay, okay, right. So there are a lot of details, but let me give you a simple example where the calculations are whole number. For example, I have a node with 4 GB of memory, right? Each mapper by default takes 1 GB of memory, right? I can reduce it, I can increase it, right? This is a parameter which goes into mapper-site file, right? But 1 GB, right, it takes. By default, each mapper works on one split of HDFS block, right? Let's say if I copy a file to HDFS which has 2 blocks, so 2 mappers will be assigned for it, right? 2 mappers will be assigned for it. So this is I showed you, right? Right, let me start my DFS and let me start 68 or 69, 68 I guess, no 69. Right, my name node is up. If I do Hadoop DFS admin hyphen report, right, I can see 3 nodes are up and 1 is dead. Okay, the reason for that dead one is, I think its name is in the exclude, or it's not in the include. Let me just check. Okay, it's fine. Okay, so now all 3 are up. I go to job tracker. Right, so this is what I showed you on that day. I say start mapper.sh. So it is starting job tracker, and it will start task trackers on all data node, right? Let me copy this, go to a client which we have already set up on that day. I do su Hadoop user. Okay. So this is all we have set up till now in our previous classes. So here I say Hadoop fs-ls. Right, I do projects, ls on projects. It has a file topology.data. Right, let me copy one more file. Hadoop fs-put test underscore file into projects. Right, so now I have 2 files inside project directory. Each file is very small, right? My HDFS block size is, let's say 64 MB or even 128 MB, does not matter, but my files are very small, so each file will go into one block. So I have now 2 blocks, for one for each file. So if I run Hadoop jar Hadoop example word count, I give the input directory and I give the output directory, let's say 22. Right, forget about these warnings which is giving because one of the data node, it was part of Hadoop 2 and I moved it back, so that's why it was giving error. Right, so now it ran, right? So jog completed successfully. So here you can see what it read, what it wrote, how many mappers it ran, how many reducers it ran. Right, so if I go to job tracker page, right, so let me just go to the job tracker page, which is 192.168.1.69/50030. Right, I ran this job. See the total map tasks 2, reduce 1. Why maps 2? Each mapper will be assigned per block. Each HDFS split, 1 mapper will be assigned. So now how will I make the calculation? The number of splits I will have for my data will decide my blocks, right? And it will decide me number of mappers. So I gave you a rough calculation, right? So I'm saying 2 terabyte of data, my HDFS block size is 128 MB, my block size, I will get approximately 16,000 blocks. So I will have to have 16,000 mappers will be launched whenever I run a MapReduce job in on this data, right? Because 16,000 blocks are there, so it will run 16,000 mappers for it, right? Which my cluster does not have. It cannot accommodate that, right? So that's why we assign capacity for each user. We will say this particular user, I give you 100 map slots, 100 reduce slots. They cannot run any more than that, right? So accordingly, I will decide on what will be my computing capacity. Although my in terms of storage, I may just survive with 4 nodes or 6 nodes, but if I give them just 4 or 6 nodes, their job might take days to finish, right? I have to agree on an SLA, right? So that's why the concept of funding from a BU comes into picture, right? So let's say my cluster might not be able to meet their SLA. So I will say, okay, fund me some nodes, right? So they will fund me, let's say 50 nodes. So I will accommodate 50 nodes. So let's say if they fund me 50 nodes, each having 4 GB RAM, so 50 into 4, right? 200 GB of memory I have, right? So if I'm giving 1 GB of memory to a mapper, so what I will have to guarantee them, I have to guarantee that whenever they submit a job to Hadoop cluster, minimum they will get 200 mappers. Minimum 200 mappers they will get. I guarantee them because this is what they funded me for. Maximum they can use my entire cluster if nobody else is there. But if somebody else is there, I guarantee you 200, right? So that's why we calculate. So we will see this in performance part. There are a lot of things which goes into it. Okay. So now let's move ahead. Another important part is logging, right? How you configure the logging in your Hadoop cluster. So by default, if any node I go on, right? Let's say I go on name node, cd Hadoop etc cd Hadoop config pwd wherever I have untarred my Hadoop vi Hadoop env.sh, right? If I go in this file, there's a parameter which will tell me where the logs will be written. So by default is wherever your Hadoop home is, under that there will be a directory called logs. So where we have defined home, cat.bash profile, I've defined Hadoop home on this path, wherever we untart, right, which we saw in our previous classes. So in this directory, if I do ls Hadoop, there will be a logs directory in which logs will be written. I can open any log, right, which will contain information about communication. If I'm on a name node, any block writes and everything, and data node will also contain different information. Okay, so now I can control this logging, right? I can control this logging behavior. So what does it mean? I can control the verbosity of this, right? I can say whether I want just info debug similar to any Linux daemon, right? Syslog we have, right? The same way we can control here as well. So how we can control? Cd Hadoop config directory. If I go, I do ls-l, right? In this I have log4j properties file. If I open this file, this is by default defining me what should be my log. By default it is info, right? I can change debug, warn, all those, right? Accordingly the logging will change, right? So this logging has also to do with Gangly. I will show you if we get time in the last class what this DRFA and all this means and how we integrate with Gangly and all, right? What will be the date format I want, right? When I'm doing ls-l here, right, on my any of the logs, it is writing a format, a role format, right? Right? How they will be rolling, we can control it, right? So same thing as in Linux, each daemon will write a log. It uses the logging facility on the of the operating system on which it is running, right? For example, syslog on Linux, right? It will use that. I can redirect the log to multiple things, right? As we do in syslog, I can have a central logging and all that. I can do multiple ways, right? I can control, if I do Hadoop, hit enter, I can control the logging for a daemon also, right? By using either the log4j file, or I can set it from a command as well, right? I can set up what should be the logging for that particular daemon, right? But in production, what we do is we will not be going for verbose and all those outputs because it will generate a lot of logs. So what is the challenge we have in Hadoop, running Hadoop in production, collecting logs? Your clusters will be maybe, let's say, 400 node cluster. How you will capture the logs for them, right? So in old ways or old systems, what we used to do was we will configure syslog as a central server, and we will be sending all other syslog outputs to it. But nowadays what we do, we use Splunk, right? There's a tool called Splunk. What it does, it's kind of a log aggregation tool, right? So you configure an Splunk agent on each node, which will send a log to a central server. It has all that visualization, GUI and everything, and you can see all the logs, right? It is similar to what we used to do in syslog, but it has a front end UI to that with little bit more powerful analytic features. Okay, now let's look at, now start with our main thing. Main thing means our Hadoop 2. So up till now we discussed Hadoop 1, right? I have set up name node, data node, all those things we have seen, right? So the naming convention is little bit confusing, right? If you are starting now, it's fine. But how the naming convention started, right? When Hadoop started, right, it was never thought of as a enterprise product or a production quality product. It was started as more of a kind of a testing, right, and kind of a lab environment project. So their versioning started as 0.1, and it went like this: 0.18, 0.20, right, 0.23, like it went like this. So what they did was to make it more meaningful, right? How versioning works. Any version we look at, it has a major number, minor number, a kernel, for example, or any software release. By looking at the version, we can might make out whether it's a stable release, what is the major number, what is the minor number, depending upon even or odd number, right? So what they did was they followed that practice. What they did was 0.20 was changed to Hadoop 1, right? They started calling it as Hadoop 1. 0.23 they called Hadoop 2, right? Features. In this, the latest stable release is 1.2.1, the one which we are running, right? Further development has stopped on this version. There's no more Hadoop 1 being committed by Hadoop community, right? Apache Hadoop. This is the last stable release of Hadoop 1 because people have moved out of it. 0.23 changed to Hadoop 2.0, right? So currently, the latest stable release which was released this month only, it is Hadoop 2.7.1, right? It got released only last week. So as there is a practice for any other software, always go for stable release in production, right? Do not go with a beta. So how Hadoop 2 is different from Hadoop 1? First thing, right? Let me write Hadoop 1.0 and let me write this is Hadoop 2.0, correct? First difference is, let's look at the HDFS part first, right? And then we will look at the differences at the computing part, right? At the MapReduce part. First different at the HDFS part. Namenode is a single point of failure. Means if Namenode goes down, your cluster is out. Single point of failure. Here we have HA, right? High availability. So here, as I explained you, in Hadoop 1, we have secondary Namenode, but it is not a highly available Namenode. It is not a failover Namenode, right? Name is misnomer. It is a secondary Namenode which does only a backup and checkpointing, right? If your primary Namenode fails, you will have an outage. Hadoop 2 introduced a concept of high availability as the HDFS layer. I can have two name nodes, only two, right? Still, you cannot have more than two high availability name nodes, right? I cannot put three. It will not let me start my cluster, right? We will do a practical on all those things, but let me explain you first theory. High availability. Second point. Here, how big my cluster could be was limiting factor. Why? Because there was only one name node, right? How much memory one single name node can have, that was limiting the size of my cluster. But in Hadoop 2, there is a new concept called federation, which is introduced, right? Federation is not yet used in production because you don't have that big clusters. For 10,000 node cluster, you will not have that big clusters, right? One single cluster of 10,000 node, but this feature is available, right? I will explain you what federation is. right? At the MapReduce layer, what is the difference? In Hadoop 1, we were using MapReduce framework 1. MapReduce 1.0 or 1.x we call it, right? MapReduce framework 1. So here what we were running, only map and reduce. We cannot run any other framework. For example, I cannot run parallel computing. I cannot run MPI stack. I cannot run Giraffe, right? These are all framework, computing framework. I can only run MapReduce. Here, there is a new framework introduced called Yarn, yet another resource negotiator. It is a framework, right, which is called Yarn, yet another resource negotiator. So what this does, with this, I can run MapReduce version 2. Why it's called version 2? Because new MapReduce was written which could run on Yarn. Yarn is a framework, right? Do not think Yarn and MapReduce are same. Yarn is a framework on which I can run MapReduce, I can run MPI parallel computing, I can run Giraffe, right? I can all these things, right? Giraffe is GIRAPH, right? It's just a framework. Second point here is job tracker was doing lot of tasks, right? Job tracker was a single point of failure in the MapReduce layer also, and it was doing lot of tasks, right? So let me explain you a recap here on the job tracker part. So if you remember this diagram, we discussed in our class 3, if I remember correctly. Whenever we submit a job to the job tracker does two main things. One is resource management and job scheduling. What does it mean? Let me help you recap if you have forgotten. This we discussed in our class 3, I guess. So this is job tracker. So job tracker has two parts. One is scheduling. It will schedule jobs, and it will do resource management, right? Resource management. So whenever a job is submitted to it, it will keep track of the status of that job, whether how much the job completed, what is the state, whether job failed or not, right? Every scheduling information it will keep. It will also do resource management, means if I have two data nodes which have task trackers running, this resource manager will know that what is the available resources on each of the data nodes. Means task tracker will send a heartbeat to the resource manager saying I have 2 GB available, so you can run two mappers, right? Each mapper takes one, so it will say I have 2 GB available. So job tracker will decide that okay, this data node 1 has task tracker running on it, which is saying me that there is 2 GB available to me, so I can fire two mappers on it. So job tracker is doing a lot of tasks here. It is doing scheduling for your entire cluster. You have a 4000 node cluster, you have 1000 jobs running. Job tracker is the only sole owner of it, which will be doing everything. So problem here will be you need to run job tracker on a very powerful machine, right? Having good amount of memory, 128 GB, maybe 256 GB, right? A very good machine. Take care of failure, take care of failure by providing redundancy, power supplies and all that, right? Single point of failure. If job tracker goes down, outage. I cannot submit jobs, right? I can read write data, but I cannot compute, right? This disadvantage was there. So in the new framework, what they did was they removed all those things. What all those things they removed? Two changes they made. One change was at the HDFS layer. They put high availability into HDFS, right? Namenode is not single point of failure. they also build up a high availability in the job tracker. Now I can have multiple job tracker roles. Rather than having a single machine, I can have multiple machines, and also I can divide the role. Instead of saying to single node to do scheduling and resource management both, I can segregate the parts of a daemon. I can set up a node 1, node 2, and I can say scheduling will be done by node 1 and resource management will be done by node 2, right? What I'm doing is I'm reducing the burden on job tracker, and that too with high availability, right? For example, I was running only one single JT. If it fails, outage. Here I can run two nodes into HA at the MapReduce layer also, right? If one node fails, other one will serve the request. So I have high availability both at HDFS layer and the computing layer, right? So we'll see practical of all this. Don't need to worry. It will be more clear. But what change came into it, right? Into the new framework. In HDFS part, the components remain same. I have name node, I have data node, right? Same name, same concept, everything same, no change. But what we had in MapReduce 1 was job tracker, master, task tracker, slave in Hadoop 1 or in MapReduce 1. But in MapReduce 2, right? Or should I say yarn framework? What I can do, I can run MapReduce, I can run something else, right? So mostly for Hadoop, we are talking about MapReduce. So when I say yarn, job tracker has been replaced by a new daemon called resource manager. MANAGER. So now instead of job tracker, you will call it resource manager. You will not have a daemon called job tracker, right? The same is if you see in Hadoop 1, if I go here and if I do JPS here, it is showing me one job tracker running. This is no longer available in Hadoop 2. That daemon has been changed to resource manager. Task tracker has been changed to node manager, right? Manager has, right? In addition to this, two more things have come up here. One is application manager and application master, right? Application master, right? Two more daemons have come, right? Name have changed for two daemons. From job tracker, it is called now resource manager. Task tracker is called now node manager, and two more daemons have come: application master and application manager, right? Don't need to worry about all these names and all that. You will get used to it, right? As we go along, you will get used to it. So now instead of job tracker, resource manager is my master. Instead of task tracker, node manager is my slave. So communication is same, right? Job will be going to resource manager as it was going to job tracker, and in job tracker what it was doing, it was sending to task tracker. Here there's a slight change. Each job controls its own destiny, right? So what does it mean, right? Let me explain you this. So in job tracker, what was happening? Job tracker was the sole controller. As I explained you, if you have forgotten, please go and rewatch the class 3 video where we have talked the details of job tracker, right? Job tracker will say to the task tracker, run mapper, and it will ask from task tracker what is the status. Task tracker will say I am done with mapper. Then again job tracker will say run this mapper or run this reducer. All commands are fired by job tracker. Job tracker is keeping an index with itself, what jobs are running where, what is its state, what are the resources on each node. Everything is taken care by job tracker. If job tracker dies, all jobs are gone, right? All jobs are gone. But in new framework, resource manager, what is happening? I get a resource manager called RM. A job is submitted to it. Let's say J1. I have data nodes, right? Let's say D1, D2, D3. Now they have node manager. Node manager running. Instead of task tracker, it's running node manager now, right? Node manager is an improved daemon. Resource manager is also an improved daemon. So when a job comes here, first of all, same communication is happening, right? Node manager is also sending a heartbeat to the resource manager saying I'm alive, because it should know that that node is there. Similar to task tracker, it is sending heartbeat saying I'm there, and these resources, these many resources I have, same thing, right? But now what is the difference? Let's say a job J1 comes to resource manager. It will not contact name node at this point. In job tracker, what was happening? It has to contact the name node immediately to know where I have to go and submit the job, because it has to know in advance that the job which I have to submit has to work on this data set, which is on data node 1 or 2, right? So it was contacting, job tracker was contacting name node directly here, right? So here resource manager is not contacting. So what it is doing, it is firing a job, firing a request rather, right? Not job, to any of the node manager, right? What it is saying, create a container, a job is coming. It will fire to any of the node manager depending upon the resources available on that box, right? It is not checking for data, where data is, right? It will fire to any resource manager and tell it create a container, right? So what it will do, it will create a container. Container is a JVM container. So when it fires a command JVM container, what it does, this container when it is created, it will fork an application master. Application master. The job J1 which got created, which was submitted, will be passed to this application master, right? To the application master. This application master is the one which will contact the name node to know where the files are, right? Where the files are, on where it has to work. It may be on same node, it may be on different node, right? And over there it will go and fire the yarn child actually, right? Yarn child, another container which will actually run the map and the reduce, right? I know it is getting complex, but I will explain you this again, right? So what is happening? Job is submitted to MapReduce to the resource manager. Resource manager will contact the node manager, any node manager, tell it saying get ready, a job is coming. It will create a container, create an application master. Job will be submitted to the application master. Application master will contact name node to know where it should launch the actual jobs, which is called yarn child, which will run the MapReduce job, right? It will contact name node to know where the file is. Now what is happening, this application master is now responsible for running map and reduce, right? If any job fails, resource manager is not responsible for rerunning it. Application master is. So what is happening now? Delegation is happening. Initially job tracker was doing everything. Now what resource manager has done? Resource manager has created one more subordinate, which is AM, and saying it, you take responsibility of J1. Anything related to J1, mapper has to run, reducer has to run, rerun the job, whatever will be taken, decided by AM. If AM itself dies, then resource manager will come into picture, create a command, ask node manager to create another AM. Otherwise, resource manager will not come into picture, right? So now let me just clear the screen, go back little bit. So I have here a resource manager, a job is coming, J1, right? This is whole is called RM, resource manager, right? Main server, daemon, right? It will have scheduling, right? It will have application manager as well, right? Two parts it will have, right? It will be doing scheduling and all. It will be doing, it will be aware of resources, and there will be one more sub part of it which is called application manager. So what is the role of that? I will explain you. So when the job comes to J1, it will tell the node manager, get ready, there's a job coming, right? It will tell get ready, job is coming. What it will do, it will create an application master, right? This is application manager, this is application master. It can create on the same node or some another data node, does not matter. This application master will actually launch your MapReduce, right? So what is happening is this application master is actually keeping a mapping between the job and the AM, right? So the job which are coming, right? Let's say a J2 may also come. So how will you know that which application master is for which job? So this application manager is kind of maintaining a bookkeeping. It is maintaining an index with it. It's saying job J1 is assigned to AM1, right? Job J2 might be assigned to some application master 2, right? It will keep a track with it. So AM1 and AM2, they are responsible for their respective jobs, not resource manager. So what is the advantage? We are reducing the load on resource manager, right? And if some failure happens, it is AM, each respective application master which is responsible for rescheduling the job, resubmitted the job, all this thing, not application master, not the resource manager, right? Delegation happens, and I can do high availability, and I can run this component separately. Means I can separate this itself on two different servers. I can run resource management part and the scheduling part on two different servers, right? Instead of running, let's say this is running on one server, I can separate this part and I can separate this part, both part, to run on two different servers. I can further reduce the load on them, right, by breaking them down. So this is what I'm explaining here. So first thing is resource manager. It is similar to your job tracker. It is the master of your cluster. Node manager, similar to task tracker, runs on each data node, takes care of execution of the container. It is not executing MapReduce. Remember, over task tracker was executing MapReduce. Here node manager is not executing MapReduce. It is just creating a execution container which will be your application master, which will actually run your jobs. Application manager will be the one which is coordinating with the resource manager and kind of doing an indexing. So this is how structure will be. Before yarn, I could not run this all thing. Streaming, Storm, for example, you cannot run Storm, right? All these are real-time analytics frameworks for Hadoop. Hadoop is a batch processing. What does it mean? I put some data into HDFS, process it. What about real time? Right? Hadoop is not designed for it. So there are tools like Storm, Spark. If I have to run them, I cannot run in the old framework. I have to put yarn. In yarn, I can run anything. I can plug in anything. I can run MapReduce. I can run Tej. Tej is again a contribution by Hortonworks. I can run anything, right? HBase runs in Hadoop 1 also. But why they're showing HBase here? Into real-time transactions. So this is what I was explaining. Resource manager, application manager, scheduler. On the client, you will have node manager, application master, container, right? So the flow will be client will submit a job, and anyway it has to go to master, which is resource manager, and will get an application ID, right? Similar to the way we are getting job ID here, right? We are calling it job ID. This is your job ID. Here we are calling it as application ID, right? So just the name has changed, right? We are calling it an application ID. So you will get an application ID. Then resource manager will choose a node manager with the available resources, right? And that the node manager is the one which will allocate container and assign a MapReduce jobs to it, right? Rest concept remain the same. It will go and read HDFS splits, and then it will launch the sub containers, right? The yarn child and all, right? So there are a few details into it, right? So we will see that. I think you should not get confused with the terms. Resource manager, job submits, it contacts node manager. Node manager can create a container anywhere, same machine, separate machine. Application master will actually run the MapReduce jobs, maybe on the same node, maybe on separate nodes, right? So this is what the new framework is doing. Submit a job, goes to resource manager, does the scheduling, goes to node manager, creates a container, creates an application master, and application master is the one which is running your MapReduce job. So it is actually doing delegation. So in Hadoop, as I explained, at the HDFS layer, you have a single point of failure. So now you have HA available in Hadoop 2. So in Hadoop 2, what we will do, I will set up two name nodes, NN1 and NN2, right? I will show you the practical on this, and I will say both are active. Both name nodes are up, right? What is the difference here? I have data nodes here. Data nodes will be talking to both, right? But this will be read only mode. This will be read write mode, right? And we will configure a shared filer between them where they will be writing metadata. Means the writer who is writing in the write mode will be obviously can edit the journal. It will be writing to a common location which will be an NFS mount, and the other will be reading it. And when this goes down, this becomes start serving. It comes out of read only mode, becomes read write, right? So this is how the concept is. So this is how this is different from the first setup which we used in Hadoop 1. In Hadoop 1, what we had was I had a name node NN1, I had a secondary name node, SNN. I had data nodes. Data nodes were talking only to this name node. They were never going here, right? This is not true, right? They were never going to talk to secondary. They were only talking to one name node. What was happening? Secondary was going to primary, pulling fsimage and edit, right? So let's say if this fails, what I have to do? I have to go to this host, change its host name IP and restart it. Then only these data nodes will start pointing here, right? Lot of time will go. But in the high availability, data nodes talk to both always. So the switchover time is minimal. So now how high availability, how we can do high availability, right? There are two options actually available in Hadoop. One is using shared filer, means I will have two name nodes. So now here the name has become from secondary to standby, or the name was secondary. Here it is standby, means both having the NFS daemon running, both having the name node daemon running, right? But this is read only, this is read write. They are writing to NFS. Blog reports are sent to both. Second method is using a zookeeper, similar to a quorum disk, right? How cluster works with the help of a quorum voting mechanism. We will set up a quorum nodes which will do the voting, and they will decide whether the failover should happen or not, right? Automatic failover. This is a manual failover, means the administrator has to execute a command for the failover to happen. When I say execute a command, you can write a script, right, which can execute and do a fencing for you, SSH fencing. For example, what I will do, I will be checking this similar to how you check for monitoring, right? I will check for certain ports. If they are up, my cluster is up, right? Name node is active. The moment it is not, what I will do, I will kill the daemons here by SSH fencing, and I will start here, right? How I start, there's a command for it, right? I will show you that. Or I can use physical fencing mechanism, maybe a power controller switches in which I can turn off the power here, right, to avoid split brain kind of a scenario. Or best is I can use a zookeeper, which is automatic failover, right? So zookeeper will be checking for, there will be daemons running on these nodes, right, which will be checking the availability of servers. Whenever a service goes down means it could be network problem, not reachable, daemon dying, anything, right? It will make the other one active, right? And your disruption is minimal. The concept remains same as we used to have in OpenVMS. So I have in the audience few people from OpenVMS era. So let me give a recap here. The formula changes from different version or different operating systems or different vendors, but the concept remains same. So best, I've always liked how VMS used to handle, right? The concept is same. First of all, I will always choose odd number of nodes for automatic failover if I want. Why? Right? Why? Right? There's a reason. I will choose 3, 5, 7, always odd number. The reason behind that is, first reason is, if I have even number, how will I decide which is the winner? Because there might be two groups of two node, one saying no, other saying yes. Both have same majority of votes. Who will win? So when I put odd number, I am making sure at least one wins, either for no or either for yes, right? Looks like logical answer, but not technical, right? So let's go to the technical part now. Why we have odd number of nodes? So let me give you a formula in any cluster. Let's say I'm setting up a cluster. It may be a Linux cluster, forget about Hadoop. It may be a Solaris cluster, doesn't matter. So what is our idea of setting up a cluster? To have high availability, right? Let's say if few nodes fail, I should be able to still serve the traffic, but I have to also at the same time make sure data corruption does not happen, right? It should not be that, let's say I have a common storage and all systems are reading data from there, right? I have a storage file system locking in place, all servers are up and running, my cluster is up and running, all nodes are reading, writing data. Let's say this node goes down. I'm left with 3 nodes which are reading my storage. Everything is fine. But what if this node comes back? It might form its own cluster just with one node reading, writing to storage, right? It will cause split brain scenario, data corruption, right? So this will, how we can avoid this? So in cluster, we had a concept called voting mechanism, right? So each node will vote saying, I am there, kind of an attendance mechanism to say what should be the decision whether I should form a cluster or not, right? So let me give you an example. Let's say n be the number of nodes I have, right? N be the number of nodes I have. So let's say n is equal to 3. I set up 3 nodes in my cluster, right? So I have to decide as a cluster administrator how many nodes I can afford to fail. Can I let my one node to fail and let the cluster run? Right? Obviously, that's what I want, right? That's why I'm putting multiple nodes. Can I afford to fill 2 nodes and still let the cluster run? How should I define it? So what happens is whenever we enable a cluster software on the nodes, there's a voting mechanism which gets enabled, right? What it does by default, each node contributes 1 vote. So before starting the cluster, I will say a quorum. Quorum is the voting mechanism which decides the stability of your cluster. Quorum is the voting mechanism of a cluster which decides on the stability of a cluster, whether my cluster should be up or it should be shut down. Right? This is what decided by the quorum. Quorum is based on voting. So there are 2 types of quorums: expected quorum and calculated quorum. Right? So what is expected quorum? Expected quorum is the quorum which I pre-compute when I am setting my cluster, right? So I say I am the cluster admin. I have 3 nodes. So what will be my expected quorum? So I will use the formula from VMS. Really very good formula, works very well. N plus 2 whole divided by 2. So if I have 3 nodes, 3 plus 2 divided by 2 gives me a value 5 by 2 is equal to 2.52. So my expected quorum is 2, right? Why n is equal to 3? Because 3 nodes, each node contributing 1 vote. So I'm getting 3 votes. I'm saying plus 2, the formula whole divided by 2. So my expected quorum is 2. So the rule is during when I start my cluster and my cluster starts running, as long as at any given point, the number of votes which I get during the lifetime of my cluster satisfy the condition of expected quorum, my cluster will be marked stable. So what does it mean? Expected quorum is 2. Let's say I'm running my cluster. One node goes down after 1 hour. quorum recalculation happens. Again, it does n plus 2 by 2. What is that? 2 plus 2 divided by 2. It is 2. So the rule is, as long as expected quorum is less than equal to the calculated quorum, right? Or you can say the other way, as long as the calculated quorum is greater than equivalent to the expected quorum, my cluster is stable and up and running, right? It is up and running. If one more node fails, this will become 1. My entire cluster will be shut down to avoid split brain scenarios, right? This concept is clear. Now let me show you why odd. Let's say if I don't take odd, I put 4 nodes into my cluster. I start by 4, no problem. I can put as many nodes I want into my cluster. Expected quorum, let's calculate. Q expected is equal to 4 plus 2 whole divided by 2 is equal to 3. So I get expected quorum 3, right? Calculated quorum. Let's say I start my cluster is up and running. After some time, one node fails. Now it becomes 3 plus 2 whole divided by 2, it gets 2, right? So it is invalidating my formula. What formula? Calculated quorum should be greater than equivalent to expected quorum for my cluster to run, which is not true now. So what is happening? Just one node failing will mark my cluster down if I have even number of nodes, because just change in one vote is decreasing my value of quorum, so it will fail. That's why if I'm running even number of nodes, failure of one node will change this formula for calculation. Odd number will not change for one node, right? Same is the case when I'm bringing up the nodes, correct? So this is the rule, right? It has a lot of details how why it was done with into this, right? Probably if somebody is interested, they can drop me an email offline. I will share a very good article, and all those people who are from VMS background, they have all the materials which talks in detail about this. So the rule is always go for odd, right? If I put 5 7, better, right? But it will waste nodes for me. So similarly here I have 3 5 7 nodes which will decide what should be the decision, correct? So what will happen if one of the node itself fails? I can still keep my cluster running with 2 nodes. So what are zookeepers here actually, right? They are voting machines, right? Similar to the concept I have explained. What they do, zookeeper is a coordination service. Zookeeper is a coordination service. What it does, it coordinates the communication between various components. It takes a decision whether particular action should happen or not. In this case, whether a particular node should be active or not, whether it should fail over or not, right? So this is the decision which is taken by this node depending upon the voting mechanism. Okay, so now we'll see all this in detail, right? But let's move to Hadoop 2 and start with Hadoop 2 cluster setup. So I will be using the same setup, but we will change the configuration, right? So I'm here having, let me just start my other machines. So I will do stop DFS and I will do stop mappert, right? All those people who have attended first 2-3 classes, they will understand what we are doing, right? I'm stopping the entire Hadoop cluster in one go. So now exit ls-l. So what we did in the first day? First day what we did was we set up Hadoop 1. What I did was I went to Google, I searched for Hadoop download. Right? It pointed me to the Hadoop repository, right? Where I can go, it's under Apache license. So I can go download Apache, right? Go here, I can download anything, right? For this is one we have already used Hadoop 1.2.1. Now we are concerned about Hadoop 2, right? This is the latest stable release 2.7.1, right? It got released this month only. I can choose any of these versions, right? 2.6 really very good, deployed in production currently. 2.5.2, right? Your choice. Use a tarball, not a source, right? Source you have to compile. Use a tarball, right? 2.6, 2.7, any of these, right? Your wish. Let me see if anybody has any questions. Okay, so I have already downloaded 2.6.0, right? So what I will do, ls-l in the Hadoop directory, home directory, we already have untarred Hadoop 1.2, which we have been using till now, correct? So how will I do now? I will do tar hyphen xzvf. Now I will untar into home Hadoop. I'm untarring 2.6.0. 7.1 why I'm not using, because I have not tested it, right? So I'm not sure what issues it might have. So I have not tested it. So that's why I'm not using 2.7. 2.6 I have been using for quite some time, and this is what is currently running in productions. People have not moved to 2.7 because it came only this month. ls-l/hadoop home Hadoop, you can see it has been copied, untarred here. Permission root, right? So I will do first thing, change ownership recursively to the user Hadoop slash home Hadoop. I'm changing the permission, right? So simple stuff, correct? Now I will change back to user Hadoop ls-l. So now you can understand why we did symlink, right? Because will be very easy for me to just remove the symlink from Hadoop, right? Symlink is gone, and point the symlink to 2.6 because I do not need to change anything now, right? So what I did initially, symlink was Hadoop pointing to 1.2. Now I have simply pointed it to 2.6, right? So now let me show you the difference. First of all, in Hadoop 1.2, the directory structure was under Hadoop we had config directory in which we had all the config files. We had some example jars. We had a bin directory where we had all our binaries and commands, right? But in Hadoop 2, what has happened? There is no config directory. Difference between Hadoop 1 and 2 is there's no config directory. So the structure has become more similar to how we have in Linux or Red Hat. Our configuration files goes into etc. So same Hadoop 2 started following. All our config files will have a under directory etc. Under etc there will be one more directory called Hadoop. In that you will find our all config files. Same config files what we have seen in Hadoop 1, right? But little bit more options. And ls-l Hadoop, I've created a symlink, I do ls, I can see bin etc. First change is config has moved to etc. Second change, in Hadoop 1, if you remember, Hadoop 1 bin directory, we have all these commands which we have been using, right? Start, all, start DFS, Hadoop daemon.sh, start name node, right? All this we have done in our previous classes. All this now in Hadoop 2, if I go to this as extraction under bin, you will not find it here. It has moved to sbin because similar to Linux, all your admin commands will be in the sbin, right? Same structure they are trying to follow. So all start and all that has gone to sbin now. Correct? So now I will open, I'm sitting on name node, right? And then what, cluster1.com. I will open vi.bash profile. What change I will make? Java will remain same wherever I've installed Java. Hadoop home remains the same because we just pointed the same link. But now what change will happen here? Initially the config was Hadoop config. Now it is Hadoop etc. Right? The path has changed. Yarn framework has come up. Right? What does it mean? ls-hell Hadoop. In Hadoop 1, what was happening under config directory? My core-site and hdfs-site was talking about hdfs layer. Mapper-site and all other files, they were talking about MapReduce layer. But I have to have them on the same path, same directory structure, right? But in Hadoop 2, I can put core-site, Hadoop-hdfs-site in some another path. Let's say /home/Hadoop, and MapReduce path files some other path /user/where, right? To have a little bit more control, right? I can put them separately, right? But not required, right? In production, because it will unnecessarily complicate things. So what we will do, first thing is I have to adjust for the changes which has been made in the configuration file. So same thing as I mentioned you, whatever I use, it is available in my GitHub. So you can go refer the GitHub. So I will open the GitHub for you so that you can believe what I'm saying. Right? Go to my GitHub, Hadoop 2, whatever we see use in the class, everything will be in the GitHub. Right? So now what I have to do, I have to add few more parameters. Which are those parameters? These parameters, right? Let me hit and enter and explain you. One parameter is I'm telling that the Hadoop config directory has changed. It is no longer etc, it is no longer Hadoop/config. So it will be by default looking for that, which is not. So I'm saying it is etc Hadoop now. First parameter, right? After that, yarn related parameters are optional, but I am showing you here we can do that. I'm saying yarn underscore home is also pointing to Hadoop underscore home, but it's your wish. You can keep yarn mapper files separate locations, but here we are not doing it. I'm also saying two more parameters, Hadoop common underscore home and Hadoop HDFS underscore home, right? So what parameters we are adding new? All these parameters. parameters. So here all are pointing to Hadoop home only, right? In production it will be also same, because we don't want to complicate things, right? What parameters you have to set, you can refer to GitHub, right? Second thing, save it. Either I exit it or just I source it. cd Hadoop etc Hadoop pwd ls-l, lot of files. First file vi hadoop env.sh, same thing. What you have to set up? Java home. So what is Java home? Cat, wherever you have set up your Java. I'll copy this. Same thing what we have done in Hadoop 1. I will set up here. I'm pointing where my Java is. Heap size, your wish. In my case, my node has enough memory, but for your sake, I will reduce it. I'm saying 400 MB. Right? Rest, I don't need to change any parameter. Right? I'm keeping it default. Save it. Another file, vi core-site. So what we'll be putting, let me remove this comments here, right? So as I explained you, each file is an XML file with an opening and a closing tag. So in Hadoop 1, what was the parameter in Hadoop 1 if you remember? Cat Hadoop config core-site. This was my parameters, right? In Hadoop 1, this is how I was writing. I can use all the parameters which were in Hadoop 1 in Hadoop 2, right? Not vice versa. I cannot use the parameters and the properties which have come in Hadoop 2 into Hadoop 1, but I can use the same thing into Hadoop 2, but it will give me warning. I can use this, start my Hadoop cluster, format it, whatever, it will give me warning saying this has been deprecated, right? This has been deprecated. Please use the new parameters, but it will still run. It will not be error, it will be a warning. So what is the new parameter which has come? Instead of saying fs.default.name, the parameter has become fs.default.fs, right? The default namespace it is talking about, right? So the parameter has changed slightly, right? This has become like this, fs.default.fs, capital Fs, right? And wherever I want to run my name node, it remains the same, right? You can practice with the old parameters and see, you can get the warnings, but it will work. hdfs-site. What parameter will go here, right? Here, cat hdfs-site. Let me just copy the parameter. Okay, it will not have any parameter. Okay, let me just copy SSH for your sake. 192.168.1.72, right? This is my data node, which data node 1, cat hadoop config hdfs-site. So if you remember, I was giving like this, right? I was giving like this, saying where my data node will be or where my name node will be. Metadata of my name node will be, right? So in the case of name node, let me show you. If I do cat hadoop 1.2 config HDFS hyphen site. On how we were giving name node parameter, we were giving like this. Correct? So what I was telling to on the name node HDFS file, that where my name node will store metadata. dfs.name.dir. Same parameter will work in Hadoop too, but this has again been modified and changed to a new parameter called dfs dot name node dot dir. Right, instead of simply saying name, it has been changed to that particular parameter. Right, for example, instead of simply saying data, it has become with a much more meaningful name. Right, meaningful name for that one. For example, in this one I can leave it here, it will work, but what will be the right parameter? Name node dot name dot dir. Right, same thing. If you go and refer to my GitHub, same thing I have mentioned there also. dfs dot name node dot name dot dir. Here also I can leave it like this, or I can give file. Why I'm giving this, I explained you. When we do Hadoop fs hyphen put and we are giving slash, remember, if you remember from class 4, we were running like this: Hadoop fs hyphen put slash. We are not saying the complete path. I'm not saying nn1 dot cluster 1 dot com colon 9000, right? It is by default taking that. I do not type such a long name. When I say this, it understands that I'm talking about that. But if I have to say non-HDFS, I have to promote by file. So that's why when I'm saying here file, I'm telling it explicitly to avoid any errors that it is non-HDFS space. You are not going to HDFS because metadata of the name node will be on your ext3 file system. Right, I'm saying file, right, explicitly. Right, and you can put replication also if you want here. Same thing which we saw. It is your wish. You can change to, let's say, 2. Save it. First thing, what we will do first thing, Hadoop name node format. Right, so let me do no to this. Why? I will show you one message which is coming at the top of the screen. Right, so it is saying it will format this space. I will say no. If you look at the top of the screen, see, it is giving a message deprecated. So if we are using old parameters, it will give me deprecated for each parameter. So it is saying the Hadoop command has been deprecated. Please use HDFS command. Right, same command will work, but it will give me message like this. So what I will do, same for each parameter, right? Otherwise it will alert me for each parameter. So I will say HDFS name node format. Now you will not get that message. If I go scroll the screen up, see this, that message is not there. It's a warning, right, not an error. So it's saying, are you sure? I say capital Y. Done. ls-l slash data slash name node current. It has formatted. Everything is blank now. And I will show you version here. So if you remember what was the version there in our Hadoop 1, it is -60 now. It was -45. So more negative the number, higher the version. I can go from -45 to -60, but I cannot go from -60 to -45, right? So I explained you that, and we will do an upgrade also. It will be more clear when we upgrade from one version of Hadoop to the another. So this is formatted now. I can say Hadoop -daemon, right? Daemon is not coming. Why it is not coming? Because we have not included the daemon path into it, because now it is sitting at a separate location. Which location? Not at bin, it is sitting as sbin, right? So vi dot bash profile, I will open this and I will add one more path here. I'll just copy it. I'm saying include bin as well and sbin as well. Two paths I've included, and I'm again sourcing it, bash profile, and now I will see Hadoop -daemon dot sh. If I do which here, right, so it will tell me where it is coming from, right? So I will do Hadoop daemon start name node. JPS name node is up, right? So what I will quickly do, instead of doing everything manually, scp-r Hadoop-2.6, I will quickly copy to all machines. 168.1.72. I'm copying to data node, which is 72. Cat dot bash profile. Let me quickly copy this also. I will go to data node 1, bash profile. I will modify this. Dot bash profile, right? So for the sake of time, let's configure only one data node, one name node, and one resource manager. So now ls-l, that file has come from there. What I will do, unlink Hadoop link Hadoop, right? So this is now on data node, right? So I will quickly open the files. Which file? Vi core -site I don't need to modify, because I'm telling where name node is. Vi hdfs-site I need to open. So what I will change here, I will change this to data node and this to data.dar, and I will change the path which I want to give here for my data nodes, right? So I will say file space d1, for example, right? df-h, you can see the mount points here. For my, I can give multiple disk drives or one drive, right? So let me clean up rm-rf. I am cleaning it because it has the old data, right? If you look from our Hadoop one, I don't want that. I'm cleaning it, right? Okay, let's put 2. I'm cleaning 2, right? So now I have to give one more here. I can give multiple, comma, d2, value, right? So I'm giving XML file, I'm saying 2 space 1 space 2, saving it, ls-l slash space d1 empty, d2 empty. I say Hadoop daemon sh start data node, right? So data node is up. So if I go here and do ls, you can see all directory structures has been created, right? Now let's quickly set up job tracker also, right? Instead of job tracker, it will be called now resource manager. So what I will do quickly, I will same copy this to my resource manager also. Update the batch profile. I'm removing this. I'm adding it here, saving it, doing a dot bash profile, and it is there. I do unlink Hadoop ln-s Hadoop, right? cd Hadoop etc cd Hadoop, right? pwd. So what I have to change here? vi core remains same. vi hdfs site does not matter. I can move it. vi mapped site, right? So if you look, it will be a template file. So what I will do, I will do a cp here, and I will copy this file to a file called mapped-site.xml, right? Same thing what we had in Hadoop 1, but what will differ now? What goes here? So what I will put here, instead of saying simply cat Hadoop 1.2.1 config mapped-site, in Hadoop 1 what it was having? In Hadoop 1 it was simply telling me where my job tracker is, right? But in Hadoop 2, what it will tell me, in the mapped-site, it will just tell me what is my framework, and that's all. I go here, I write it here, hit enter. So I'm telling now my framework is yarn. I can write it local here. Local means it will run the MapReduce framework 1. I can run the old mode in new framework, but not the vice versa, right? I can set up local here keyword and it will run MapReduce 1, right? But I'm showing you 2. So I will run yarn here. So there is one more file which gets enabled. If I put yarn, why yarn -site, I will open this file, and what I will put here, I will put yarn parameters. What are those yarn parameters? Let me put one by one and explain you. First two are Java classes, which are telling me what is my framework. I enabled yarn in mapped-site, and these two yarn node manager auxiliary classes and the MapReduce shuffle class, right? This you have to simply put into it, right? Which is a MapReduce framework 2 classes, right? Because everything is written in Java, as I explained you, Hadoop. So I'm just simply enabling it, right? I'm simply enabling it. Then second thing, What I have to put now? I have to put where my map this should run from here. I'm telling where is the resource tracker of my resource manager should run. Same node jt dot cluster1.com. Let me check this host name, right? jt1, right? Same machine which we are using as job tracker. I'm saying resource manager tracker should run on jt1. Where should the scheduler run, right? I have the option of setting them separately in Hadoop 2, or I can run everything on single node within a MapReduce component, right? Initially, what we are doing, distribution of name node, data node, job tracker, task tracker. Now, in addition to that, we can do distribution of resource manager components itself. I can run resource tracker, scheduler, and resource manager itself all on 3 separate nodes, right? But we don't have that many nodes here. In production also, we will be running them on same machine, and I say this one. So I'm saying different ports. So in your at home, you only need to give this parameter and the first two parameter if you want to run. First two parameters of Java and the last parameter of resource manager. These two are optional, but I'm showing you we can segregate the sub part of resource manager. I save it and I simply do scp yarn hyphen site and mappard hyphen site, and I will copy this to 192.168.1.72, the data node, right, which will be running the slave of my resource manager, which is node manager, right? So I will say home, sorry, anyway I've given that Hadoop slash etc. It is copied. If I want, I can put on the name node also, but it does not matter, right? So now it is done. So I will say in Hadoop 1, what we were doing, we were always using Hadoop daemon command, both for starting, stopping, name node, data node, as well as job tracker, task tracker. But let me say start job tracker. It will say not. I don't understand what are you saying. Job tracker is not there. Even if I say resource manager here, it will say I don't understand what you are taking. Could not find the class. So what has changed here? Instead of saying Hadoop daemon, you have to say yarn daemon, right? So the change will be in the command also. HDFS layer will start the same way. Start data node, start name node. But resource manager and task tracker, you have to start by yarn command. So I will copy this command. I will go to data node and I will say start node manager. Now node manager has come, right? So my cluster is up now with name node, resource manager, and data node and a node manager, right, in Hadoop 2, right? So this is how we set up. So we will go towards distribution in tomorrow's class. We will run MapReduce job 2 and we will see how these things go forward, right? So please set up Hadoop 2 on one node or two nodes. If you have any questions, reach out to me. And I'm not sure, have you done all your experiment practicals till now, right? We have covered a lot of things, right? So in Hadoop 2, we will not be covering all those things which we have covered in Hadoop 1. For example, rack awareness, quotas, all those. I will be telling you only things which has been added in Hadoop 2 which were not in Hadoop 1, like high availability, snapshotting, NFS, right? Those things I will tell you. right, in Hadoop 2. And then we will move to Hive, Yarn, Hive, HBase, Pig, Flume, those kind of things, right? So please read through these blogs which I have marked out. In our tomorrow's class, we will move Hadoop to a fully distributed mode, do a Hadoop upgrade, do a high availability setup using both NFS and Quorum Manager, right? Using Zookeeper. Both setups we will do. And please read, if you get chance, read to pre-reading this text. And I will, if you have any questions, you are most welcome to ask. We are already 15 minutes past the time, but I have no problems. If you have any questions, you are most welcome to ask. So here, right, so you can see node manager is running, source manager is running. So I can run any same command, right? For example, I say Hadoop fs -ls. Currently it does not have any data, right, because we formatted the file system while creating it. Hadoop fs or Hadoop dfs admin -report, right? All those commands are there, but deprecated, right? Instead of saying Hadoop, I will say hdfs. Right? So now you will start seeing fully qualified domain names in Hadoop 2. Initially you are seeing only IPs in Hadoop 1. You will start seeing those names. And how will I run the job? Let's say, let me copy a file quickly for you. Let's say I create a directory mkdir input. I'm created a directory on Hadoop cluster. Right, that directory is there. What I do, let me quickly copy a file. Put, let's say, MapReduce defaults. I've copied there. So now how will I run that job? I will say Hadoop. I can go by Hadoop jar method. Same path. Path has changed little bit. Initially the example jars were sitting directly under Hadoop folder. Now it has gone little bit deeper into the directory structure. Right? Path has changed. So share Hadoop MapReduce word count input / out. Right? So I will show you, instead of saying Hadoop jar, you can also say yarn jar. Execution will be much faster here. Right? You will see this job completing very quickly. Running job, it gives you a job ID. And if I go here, I do JPS. Okay. Oh, I think I have not updated DNS on this. Okay. So anyway, we'll see that tomorrow. All these things, running jobs and all. Okay, guys. So any questions you have, please let me know, or else we can close, and I will see you tomorrow at the same time. So tomorrow again, it's a very important session from high availability perspective. We'll be setting Hadoop 2 cluster again, right? So there are few new people in the class today, so I'm not sure they got the context, because we have already looked into this configuration in a lot of detail in Hadoop 1. I have just shown the changes what has happened from Hadoop 2. So tomorrow we will continue on this one, set up the 2 cluster again, high availability and all, do a Hadoop upgrade. and I will show you some of the features, advanced features as well. Okay guys, so thank you very much for your time. Have a nice day ahead, and I will see you tomorrow at the same time, which is 8 p.m. tomorrow. Thank you very much. Bye bye. And one update for anybody who is joining new or missed the previous classes, I will share you the videos again, right? So we are sharing the videos you can download of the class, and also any of the previous class as well, right? So please, you're most welcome for all the classes. I will share them, all the recordings if anybody wants it, and please let me know on that. Thank you. Good night.